In Chapter 5 you learned that wind is the result of pressure differences between high and low pressure. So-called zonal winds blow along the lines of latitude, so generally from east to west or west to east, while meridional winds move along the lines of longitude, so generally from north to south or south to north. Even though our atmosphere is highly variable, we find a well-defined pressure pattern across our globe, which defines the general circulation of our atmosphere. A simplified model for the global atmospheric circulation is the three-cell model. The three-cell model consists of three cells that describe general features of the global atmospheric circulation. The general circulation is driven by four major pressure systems: the equatorial low, the subtropical high, the subpolar low, and the polar high. The Hadley cell describes the circulation between the equatorial low and the subtropical high. The Ferrel cell describes the circulation between the subtropical high and the subpolar low, and the polar cell describes the circulation between the subpolar low and the polar high. Air in the tropics is heated through high solar angles and relatively constant day lengths. Air becomes heated, expands, and diverges toward higher latitudes. The equatorward boundary of the Hadley cell is characterized by expanding and ascending surface air that forms the equatorial low. Other names for the equatorial low are Intertropical Convergence Zone, ITCZ, or doldrums. The ITCZ generally follows the vertical solar rays, which means it moves into the northern hemisphere in summer and in the southern hemisphere in winter. It is usually characterized by clouds and heavy precipitation. The ascending air diverges polewards in the upper troposphere. Air at the poles is cold and dense. It sinks down and produces an area of high pressure. Air diverges from the polar high pressure cell and flows towards lower latitudes, to the south in the northern hemisphere or to the north in the southern hemisphere. The air that has risen over the equator, moved polewards in the upper troposphere, descends between 20 and 30 degrees latitude, forming the subtropical highs. The sinking of the air causes its warming, which creates clear, dry conditions. Sinking air masses are usually associated with little horizontal air movement. This region is also known as horse latitudes. Notice on these pressure maps that these high pressure cells exist throughout the year, in winter and in summer. Warmer air from the lower latitudes collides with cold air from the polar region in the mid-latitude or subpolar region, which is around 60 degrees latitude. The source of the warm air is the subtropical high. The source of the cold air is the polar high. The subpolar low results from convergence of air masses and rise of less dense warm air over the cold air. You can see that throughout the year these pressure systems might change their position and intensity, but the basic pattern remains the same. These high and low pressure systems result in very distinct wind systems that we find on our planet. The persistent winds from the subtropical highs to the equatorial low on both hemispheres are called trade winds. Surface air flow is subject to Coriolis deflection. Therefore, winds blowing from north to south, from the subtropical high to the equatorial low in the northern hemisphere, result in northeast winds, known as northeast trade winds due to their persistence. Winds blowing from the south to the north, from the subtropical high to the equatorial low on the southern hemisphere, result in southeast winds, known as southeast trade winds. Air moving from the subtropical highs towards the subpolar lows is again subject to Coriolis deflection and causes westerlies in both hemispheres. And finally, air that moves equatorward from the poles, again deflected by Coriolis force, creates the polar easterlies in both hemispheres. Here is the whole system one more time. Air rises over the equator, flows poleward in the upper atmosphere, and sinks over the subtropical highs. From the subtropical highs, air flows back towards the equator in a wind system which we call the trade winds, northeastern and southeastern trade winds. Air flowing poleward from the subtropical highs forms the westerlies in both hemispheres. Air flowing equatorward from the poles forms the polar easterlies.